Hello students, welcome again to the new segment. In this segment we will be looking at the naive Bayes classifier. So let's read some data first. Remember that we have downloaded the RS dataset from the machine learning repository in the previous lecture, so we are using the same dataset over here. And since it's stored in the C directory, so I just read it from there. Okay, so now we have the data in the variable t, and now we are ready to use the naive Bayesian classifier. So the function that we need to use is the fit c and b function, and again it needs two pieces of information. One is the table data structure, and the other one is the variable name within that table. And we need to return it in certain variable, and it will build the model for us. So once the model is built, we can note that it has very similar kind of properties that were returned when we made a model based on the Cannon classifier, such as the predictor names. So these are the variables that has taken part in making this classifier. Variable 1, variable 2, variable 3, variable 4, and variable 5 is our response variable in this case. Similarly, the class names, and then the number of observation it used. So these two are different properties, right? So they were not being there when we were studying the Cannon classifier. So these are actually the distributions, the distribution names that it used in order to calculate the probability for each individual variable within a certain class, right? So please recall that since the data that we are using is not a discretized data, rather it is continuous. So if you have a look at some of the rows, we may note that. We may note that the variable 1 is continuous, variable 2 is also continuous, continuous, continuous. So in that case, it is going to calculate the probability based on certain distribution. So the distribution it used by default is a normal Gaussian distribution. So it has used the normal Gaussian distribution for variable 1, variable 2, 3, and 4, and so on. So if you want to have a look at the specific statistics, that is the mean and standard deviation of each variable within a particular class. So that information is actually stored in this property, that is the distribution parameters. So you may have a look at it. And now it will return a cell data structure. We are not going to cover the cell data structure in detail. If you are interested, you go ahead and take my course. Rather, we will just look at the values, right? So this data structure contains essentially four columns, and it has 3 rows, right? So for each and every variable, it is going to have some statistics across the columns, and for the 3 classes, it is going to store that information within those rows. So this the information here, it corresponds to the first variable and its mean and standard deviation of the first variable for the first class. And if we want to look at what is our first class, so that is contained within this variable, that is class names. So our first class is RS Setosa. So it means that the first row contains the information, the statistics regarding all the variables for the first class, which is RS Setosa. So if you are interested in, let's say, the values here, that is the second variable, that is var2, and its statistics within the first class, that is RS Setosa. So we are going to use the curly braces and mention its corresponding location, which is, in this case is 1, 2. So this first argument specifies the rows, and the second argument specifies the corresponding column. So we are looking at the second column and first row, which means first class, which is RS Setosa, and the second variable, which in this case is var2. So if you press enter, it is going to return 2 values. These 2 values corresponds to the mean and standard deviation. The first value is the mean, and the second value is the standard deviation. So in summary, this value 3.4180 is the mean of the variable 2 for the instances in the first class, that is RS Setosa. So all the instances that belongs to RS Setosa and which belongs to its corresponding variable 2, so it has this mean and this statistics. Similarly, if you look access 3 comma 3, that will mean the third class and third variable. So the third class here is rs virginica. So it means that for the third variable var3, all the instances that belongs to rs virginica class, the mean and standard deviation for the third variable for those instances are 5.5 and 0.5519. Right? So this is quite important and distinct from the nearest neighbor. These statistics were not being stored in that case because the canon does not need this. Okay. The other thing is that if you want to modify this default distribution that it uses, because for some reason we may be told that the first variable is not following a normal distribution, rather it's some other distribution. So there are some, you can mention that, and you need to use additional parameters while you try to build your model. And that additional parameter is the distribution, and then you can mention the distributions. Right? So there are some options that you may try. That is the kernel. I will give you a list of some other options that you may try over here. There is some other distributions that the MATLABs allow you to take advantage of. Right? And then when you press enter, it is going to update that. Right? So it is now saying that the distribution names are kernel, normal for the second variable, then kernel for the third variable, and so on. So if you are curious and you want to know what are the available options over here, so I will briefly tell you that. So the first option that you may try is the multinomial. So multinomial distribution as well. And the other one that you may try is the multivariate multinomial distribution, MUMN. And then of course the kernel, and then the normal distribution, that is the default option. So there are 4 options that you may try here for different distributions. And if you want to have a complete documentation of that, I would strongly recommend you to go to the documentation page of fit-CNB function, and then click on the naive Bayes, and then the class information. And then within here, you can check the properties. And then within the properties, you need to go to the distribution name. And then you may find the corresponding information over here. That is, the first option is the kernel. It is kernel smoothing density estimate. Then the multinomial. Right? So if you click here, it will give you more information about this distribution. Similarly, the multivariate multinomial distribution. One other important property is the prior probabilities that you may use, that it calculates from the data set itself. So if you look at the default prior probabilities, it is calculating it from the data set itself, and it is 0.3, 0.3, and 0.3. So if we calculate the resubstitution loss based on the current model, so you may note it has a value of 0.033. Right? So for some reason, you may suspect, or you may be given, that the prior probabilities are not the ones that it calculates and determines from the data set. Rather, you want to give it some other values, such as 0.5, 0.2, and 0.3. So you have, it may be given by an expert, it may be an expert opinion, or you may have some other process based on which you may have accessed the prior probabilities, or it may be given to you. So when we update that, and when we calculate resubstitution loss again based on the new probabilities, so we may note a slight change here. Right? So it means if we look at the the default probabilities, so with the default probability, it has an error of 0.033, the training error. And here it has now increased a bit, right? Though the increase is not that much, so we may suspect that these probabilities are as good as the initial probabilities or the default probabilities. One final note is that please take care of the scaling issues before training your model. Final note is that it can work with multi-class labels as well. That is, it can classify not only the binary classes, but if there are multiple classes, more than 2 classes, it can still work. So hope you're enjoying the course. That was a little bit brief introduction about the naive Bayesian classifier. Hope you're enjoying the course. See you in the next segment.